Okay, guys. Okay, so what we've been doing the last time, if you remember, okay, it was the networking. Now, the networking is a broad, is a very big topic, guys. It's very, very big topic. You're gonna be having 4 Cisco courses which are related to the Cisco provider. They will explain you how the networking operates, how the network operates, and how eventually, specifically the Cisco devices, they operate within the networking in themselves. So, what we've been doing very fast, just to remind you, first of all, we said what is a host, okay, and we identify the hosts that if it's any networking devices, it could be network device, it's supposed to have something which is called network interface card, okay, and with this interface card to a medium, it's connecting to other hosts or hosts in the network. That's why nowadays we have the internet, right? Because there are millions of hosts everywhere and they're connected, or also it's called interconnected to each other. Okay? Now the medium, we said it could be a copper cable, coaxial cable, or lately nowadays the UTP, shielded twisted pair, as well as it could be the air and the electrical interference which is going through the air, actually all the waves, as well as it could be plastic or glass for the fiber optics. Okay, so these are the mediums nowadays which interconnects all the hosts. And the most important role of any host actually is to share with the other hosts resources. And if you remember, in the beginning we spoke that the way they communicate or share is either service plans or peer-to-peer. I'm sorry, guys. Stop for a second. Now we spoke how our home, how it looks, how our home network actually is looking, and we mentioned that we have always 2 devices on the both sides, one in our home and the other one on the internet service provider end. We called routers, right? And these 2 devices actually interconnecting the different networks. In that case, they interconnect the internet. And actually, I told you guys that the internet itself, what it is, there are a lot of service providers like these ones, as well as a lot of these service providers like these ones, as well as big companies like Microsoft, like Oracle, and more and more and more and more. And they're interconnected to each other as well in any kind of fashion, okay? And because basically it's not visible, we don't see it very well, that's why they call it cloud. Okay, that's the reason they call it cloud, because it's cloud. You don't know what's inside, okay? But we know what it is. There are routers. Every one of this company or every one of this internet service provider, all of these guys are inside, and that's what we call internet or cloud. Okay, easy busy like this. Now we said in our school, like that's the school. On the other side, the same thing. Right? We have our main router here, which actually allowing us to connect with the internet, with our internet service provider. We might have several floors, like we have here the number 4, number 2, and number 1. Okay, and we set every floor. In our case, even not the floor only, every room here we call it a local area network or a different network. And I said, for now, we need to know this is network 1, this is network 2, this is network 3. The meaning of this is that we making compartments, right? So network 1, whoever is inside, like let's say this very room, everyone inside might change files to each other, might work on the same project, might maybe print out on the same printer and stuff like that. That's the reason we have this network. Okay, we isolated it so people inside to be like a family, like a room, like doing the same thing. In the enterprise, you might say, let's say, this is the department of collecting money. Okay, so these 10 people who are calling people and asking to gather the money, these are different departments. On the other side, we have the department of the people who taking care of the networking, the internet system, the administrators. So that's another one. On the third part, you have the network of the people who ruling the company, the boss of the company, the chief financial officer and the people who are, the important people, so they might be forming a different network. On the other side, maybe we have the accounting department. So we don't want the ordinary callers to be able to access the files of the bosses. There is no sense. But we might want the bosses to be able to access the files of the workers, so to see what they do. And we definitely want the workers, the people who are on the call, they to be able to communicate to each other, and the bosses, they to be able to communicate to each other as well, right? So that's why we have these different networks. Okay, that's the reason. And as I mentioned, another reason might be the physical one. Like we have a classroom. Now we have this class with you guys. We don't want to mess with the class of the project management next to us. It's different thing, right? You're doing computing science. These guys are doing maybe gerontology, which is completely different. So we don't want both of us to mess. Okay? So that's why we isolate this and we say this will be our network. So between the networks, the routers are the devices which are interconnecting them. So if I would like anyway to print on the printer which is next to us in the room of the people who are doing project management, well, the router, gonna do something on the router, so we're gonna send the signal to the printer. Then we're gonna be able to print out, even though it's a different network. So the router is the very important thing. It decides who might go from one place to another, from one network to another. Now, in the network itself, okay, we have different computers, right? You have here about 40 computers. So we have 40 computers, guys. Now, all of these computers are hosts on the network. We said what is the host. That means every one of them has at least one network interface card. And, they are connected to each other. Okay? Now, if I would like to interconnect all of these guys, apparently I need more than one network interface card, right? If I would like this to be connected to 1, 2, 3, 4, 5 devices, I need at least 5 of them, right? So to interconnect all of these guys from a separate network card, which is not very smart. Imagine if I would have kept 40 and all of them supposed to be connected to each other. Imagine what will be happening. We can't pass here by cables. Here's the people invented a device, smart device, which is called a switch. So that's why we have the switches, okay? And all of these computers, instead of connecting to each other, they are connected to the switch, okay? And the switch provides all of them with the network 1, 2, or 3, whatever we have here, ability. So everyone to be able to access everyone else. Okay, that's why we have the switch. Okay, so the switch works within the network. Okay, if we have 2 different networks to connect one to the other, we need a router. That's what you need to remember from today. That's the most important thing. The router interconnects different networks. The switch is inside the network. That's the difference. Okay? Everyone understood this? Now we started talking about the digits here, remember? Well, we spoke a little bit what is the bandwidth, if you remember, how we do the what is big kilobyte, megabit, kilobit, stuff like that. Remember? When we're talking about bits, we're talking about the speed, internet, speed of the network. Then we're speaking about bits, and we said 1 bit is either 0, well, there is no signal, or it's 1, which is, there is a signal, or there is something there. So, and we said 8 bits are doing 1 byte. Now, the networking is working with bits. We said that there are some specific network protocols, which are rules, set of rules the network to operate. We said that some of them work in a different way, but they're more advanced. They work as blocks, but they're much more advanced, so we are not talking about that. The internet, as we know, is a stack of 2 protocols. It's a bundle of the protocol called TCP/IP. Okay, transmission control protocol / internet protocol. These 2 protocols are ruling the internet nowadays. Both of them, they're working by bits. only bits. There is a signal, there is no signal. There is a signal, there is no signal. Okay, that's how it works. And we explain megabyte, gigabyte, terabyte, or megabit, gigabit, terabit, how they're created. And I said sometimes, be aware that sometimes instead of 1024, well, people are trying to sell you 1000 for mega, giga, tera. So it's a good idea you guys to check this thing. Questions after? Now, the important thing, we spoke that, especially in the network, when we were talking about the IP address, which is one of the three identifiers very important for a host. We said there are three identifiers. One is the MAC address. So one of them is called a MAC address. Media access control. This is what is physically burned on your network card. Okay? It has hexadecimal there. Okay? Because it's created with this, it's 12 hexadecimals digit. Okay? It's created in this way because the combination of hexadecimal is very big. So people were trying to create any networking device to be unique. That's why they created it like this. So hexadecimal means it's starting from 1, going to 9, and then starting A, B, C, D, E, and F. Okay? That's a hexadecimal. Well, the biggest one would be 12 Fs. And so on and so forth. Okay? It will be only Fs. If you open the calculator, if you change the calculator to programmer calculator, and then you go to hexadecimal, there will be hexadecimal, and you write down the 12 Fs, and then you transfer it to decimal, you're going to see how big is the digit. It's a pretty big digit. Now, why they decided to do it like this? They did it like this because, as I mentioned, they wanted to be unique. Every networking device to be unique. Why? Well, to be traced. That's why. Okay? They want everything to be traced. Now, there is a way the hardware address to be changed. The process is called spoofing. Okay? You could change your hardware address, software. Okay? You could lie actually the device, which is your hardware address. It could be broadcasted this hardware address. Here in Canada and in America, it's called this thing. If you do it in production, you go jail. Okay, so you don't do this thing without asking, and just for what purposes you could do. Okay, you don't play with this thing. Although they created it unique, you could find out devices which have the same. It's possible to find out. Okay, but it's very, very rare. It's not so. It's important in the same network. You to have different MAC address. Now, I just said that it's very rare to have the same. Well, it's not rare if you use a virtual machine. When you create your virtual machine, let's say if you create a virtual box Windows 7, we're going to do it from the next time, I guess, or Windows 10. You created this machine, and afterwards you see, it's taking you 1 hour. Well, the virtual box is very easy because you could right click afterwards on the created machine, and you could clone it. So it will take you another 5 minutes to have the same machine back there. Now, when you cloned it, if you don't click somewhere there, I'm going to show it for you specifically, it will be cloned with the same MAC address. And if you put it into the same network, it won't work. Because the same network doesn't accept anything to be the same to a host. It's supposed to be always different. And one of the identifiers is the MAC address. The other identifier is the name of the host. So the name. When I say the name, I could call a virtual machine a second. I could call it by name. I could call it Zeus. I could call it 205x7, whatever I want. Okay? Now, the same principle. When you call it something in the same network, you cannot have the same name of the machine because it won't work. It won't work. Okay? It will give you a funny error. The third identifier is the IP address. Now, the name helps the people to know which host is which. We people, we think by names. We don't think by IP addresses or MAC addresses. It's too complicated for us. Okay. Now the machines, because They're working only with IP address and MAC address. Okay, that's what they use. So that's why we have a little bit of struggling. You know, we say the name machine don't understand IP address. Okay, that's a little bit of the tweaking process what we need to do. So the IP address or internet protocol address is a very, very important thing. Nowadays we have two versions of it, version 4 and version 6. Now version 6 has been created lately, let's say the last 20 years, and it has the same concept like the MAC address, because as I mentioned, we have about 8 billion of people and more than 40 billion of devices. So they're supposed to be, you know, they're supposed to describe these devices uniquely. With using IP version 4, we have 4.3 billion choices. 4.3 billion, which is almost 10 times less what we have at the moment as devices, which means it's not enough. That's why they created version 6. Now, afterwards, the engineers saw that the version 6 is not very easy to be accommodated and to be used. So that's why they created a hack. They hacked themselves actually. And nowadays using some technology which is called a NAT, Network Address Translation. Okay, what they do nowadays with this technology, they are able to use 4.3 billion addresses for 40 and more billion addresses or devices or hosts which are available. Okay, so they said, okay, within the network, local network, so the network which is within the network which is within the enterprise, the house, and whatever. So on that side of the router, the network which is on that side of the router on that side, well, we're gonna call it private, and we're gonna assign private IP addresses. And these private IP addresses, they might be the same in any network. So if you have a separate network, so in this classroom, in the other classroom, there are two separate networks. What is doing them separate? Then the router between them. Okay? So the router between them, say this is one network, the other one is network. I might have the same unique IP addresses. I mean, here the same IP addresses, there the same IP addresses, no problem at all. Why? Because they don't interact with each other. Or if they interact, they use this thing which I call it a NAT, a network address translation. We're not going to talk about this now. They translate addresses to something else. Okay, that's why the addresses then are again unique. Okay, they're unique for the network. So in that case, you could duplicate address if you have a router between them or a LAN. Okay, you could have duplicated IP address. That's why with 4.3 billion available IP version 4 addresses, we still are able to handle more than 40 billion IP addresses which we get at the moment. Okay? Well, sometimes it's country like India, countries like China and so on and so forth, where the people are more than billion nowadays. It's a little bit of tricky. That's why they use some of the service providers starting to use IP version 6. Okay? But most of the countries, they're still heavily using IP version 4. And in this course, because it's very short, okay, we're going to talk only about IP version 4, which is the common IP address. Questions, please? Now, an IP address, yeah.
If we use virtual machine, then the IP address will be changing or it will be the same.
Now, when we start doing, I'm going to show you. Now, the virtual machine, when you create it in general, there are several ways you to choose your network address. Now, if you use the bridge adapter, the bridge network adapter, that means you're going to bridge your virtual machine to your real machine's adapter. That means it will take from the DHCP server here, it will take an IP address from the network. Okay? So I'm going to speak what is the DHCP server very soon. So this is the server which is giving to every one of this machine an IP address. Otherwise, I need to go as an administrator, I need to write it down manually. That's why we have this DHCP server which is sending to every one of the machines is sending an IP address. Okay? So what it does, if you choose a bridge adapter, when you do it, it will bridge it and it will take from this DHCP server and it will be acting as a real machine from this environment. The same IP address range it will be here. Which is not a good idea because sometimes, guys, you're going to implement some services here on your machines, and these services might interfere with the services what we have here as administrator we already created. That's why we don't recommend you guys to use the bridge adapter. I'm going to mention this again when we start. Now, the other way is to use a NAT network, only NAT. It says NAT inside. When you use it like this, when you create a second machine, it will be having the same IP address, which is not a good idea because, as I mentioned, you cannot connect them. You need to change this address. The virtual box, since it's a free product, it's kind of shitty, sorry ladies, but that's what it is. So at certain point, it might not work. So you're gonna try and try and try, and you're gonna lose a lot of time. Now, if you use NAT network, in that case, you're gonna have, every time you create a separate machine, it will be having a different IP address from the same network. So they will be actually right away interconnected. So that's one of the ways. There are two more ways, which you're not gonna have internet in that case. You could use the internal adapter, and then you need to do something yourself. You need to. Doesn't matter. Whatever you use, Linux, Unix, or Microsoft, when you use internal adapter or cost-only adapter, there are two of them. You need to provide your own IP address, and you're not gonna have an internet. You could have internet if you put a firewall machine, which could be created could be connected. In some of the other courses, I'm gonna show you something which is called GNS3. GNS3. This thing is a platform which is free also. You could create your virtual machines, and you could connect inside, as well as you could use any network device images, Cisco, Ubiquiti, you could use whatever you have as image. And afterwards, you could create a real infrastructure with networking devices as well. And you could connect to internet as well. Okay? I'm having movies how to do this. It's very cool. They have a marketplace, so you could download even pre-installed machines and right away use them. I could provide you guys with the movie so to see and to do it. Only people who are interested. I'm not going to show it here because we don't have enough time and it needs more knowledge about this. Okay, but that's when you go further and when we start doing the server operating systems, then I'm going to show it how to do, because otherwise we don't have any choice. Otherwise, that's the choice we have only to use this software. Okay, but it's very cool. It's very cool. It's very easy to work. Other questions? That's okay. So about the IP addresses, guys. So an IP address, as I mentioned, there are two ways the IP address is to be done. On that side, they call them private. So you have here the private. On that side, you have the public IP address. Okay? Now, on that side, you have something else. On that side, actually, wherever is here, normally people are calling it local area network. LAN, a LAN. So the LAN, basically, especially when you use the copper cable, it's in the range of about 100 meters, because that's the maximum you could use the cable. Basically, the cable is, if you use it more than 100 meters, it's kind of, there is a phenomena there which is called attenuation, which is really natural phenomena. If I talk with this power of my voice, and if I open the door and start going outside, at certain point you stop listening to it. That's the same with the signal. It will attenuate depending on the length. And after 100 meters, actually, you cannot hear it after the signal. You could do something if you put a switch-like device, which is called repeater, which will repeat the signal to the next. So you need this type of devices to do it. Okay? Most of the time, the local area networks are explaining how they're done. You need to compartmentalize something. You don't need too many computers. You don't need too many computers. You need to say these computers they're used for this department, let's say, or for this classroom, or for this floor. And that's your network. You separate the network, and that's all. Okay. The other network we have is the WAN network, or the public network. Well, the WAN network basically, wide area network. Yes, wide area network. Basically, you pay for it. Okay, that's how you want to understand the difference. That's what you pay from your ISP. As well as it might be long to kilometers, miles, thousands of miles between. It might be between the continents. Okay, that's what the fiber optics are doing nowadays. Okay, and this big routing devices. So the one actually is very, very wide. That's all it says. Wide area network. Now, when I'm talking about LAN and WAN, don't forget it might be wireless. So when I put a W in front, okay, well, here it's not very, but it might be like that. You could have a wireless LAN and wireless WAN. So the wireless one is my cell phone, right? This is my cell phone, no? Yeah. So it's connected to the provider maybe 2 miles away, okay? That's why it's one. The equipment and the protocols are used there, specifically designed for wide area, for wide range. When I'm using our access point here, you're gonna see that when you go outside, there are the white one on the top. When I'm using them, I'm using the wireless local area network for my computer. And the easiest way to understand this is when you see the ranges of the IP addresses which are used. For the private range, you have three basic ranges. Before they call them class A, class B, and class C. Before, not anymore. Now this one is 10.0.0.0. This one is 172.16 up to 31.0.0. And this one is 192.168.0.0. Okay, that's what it is. That's these are the only private addresses you have. Okay. Well, there are two more. One is called a loopback address, which is the range of 127.0.0.0. Okay, we're gonna speak. You're gonna understand what is after this. And there is another one which is called a PIPA, which is 169.254.0.0. Okay, that's what it is. These are the only private addresses. These are for special needs. They're not used. These ones, basically, you create yourself. And that's what you have within the network. Everything else is a public network. Okay? And they're used mostly by the service provider. So you guys can send the internet. Once again, public working on that side, private working on that side. Public working on that side, private on that side. That's all. Okay? And you could recognize the IP addresses this way. You're gonna see when you open your they explain these are the ranges. Now, the IP addresses to work, there is another component there. Okay? The component is called a subnet mask. Now let's first see, once again, we did it once, let me just remind you how it's done. Now, the IP address, guys, is an octet. There are 4 octets there. So that means, as I mentioned, you get 172.237.60. This is a legitimate private IP address. For now, we forget. Private, public doesn't matter for us. That's a legitimate IP version for IP address. Okay? Now, it has 4 octets. So when I say 4, the dots actually are doing this. When I say 4, here's the first one, here's the second one, here's the third one, and the fourth one. Octets. Why? Because there are 8 bits in every one of them. Now, I see, we are humans. We see this in decimals, but it's not decimal. It actually, the machine is seeing here binaries. Okay? And it sees a byte. So that means the machine will see here 1, 1, 1, 1, 1, 1, 1, 1. That would be the maximum what could machine see. Then dot 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, dot, and 1, 1, 1, 1, 1, 1, 1, 1. That's the maximum what the machine will see. This is the maximum. And the minimum for the IP version 4. The minimum obviously will be 0, 0, 0, 0, 0, 0, 0, 0, dot, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, dot, again 8 zeros, and again 8 zeros. So that's the minimum, which obviously equals to 8.8.8.8. And this one you're going to tell me how much it is.
255.
Exactly. 255, 255, 255, 255, 255. Okay? You have the minimum of 4 zeros in decimal. Okay? Or 38 zeros, 32 zeros in binary is the same thing. And you have 255, 255, 255, so or 32 bits or 4 bytes, which is the maximum IP address you could have. And any combination between them. Any combination between them. Okay? So that's how it works. That's what is the networking in basics for IP version 4. Okay? So they call them octet because in Latin 8 means octet. Okay, octa is 8. That's why they call it octet, because you have 8 bits inside. Okay? So now, the subnet mask. Well, the subnet mask is a very important thing, which actually is used as a template. You use it to, if you have an IP address, to put it over the IP address and to find out what is the network. Okay? So what that really means, let me show you. Now if I say 172, 34, 25, let's say 15, okay, with a subnet mask of 255.255.0.0, okay, it has a different network address. It has a different network address of the same address, IP address, 172.34.25.15, but if there is a 255.255.255.0. So both addresses has a different network address. And why is this important? So that means this one will be network 1, the other one will be network 2. So if we would like to connect from network 1 to network 2, what device we have we need here then? If we would like to connect from this network to this network, because obviously they are different networks, what device? Well, we need a router. So we need to put a router here, which is costly, right? So if you design it this way, you need to put a router so from this network people to connect to the other people and vice versa. Okay, that's what it means. Okay, and how I know? Well, when I see the subnet mask like that, the maximum of the 255, 255, 255, basically what happened actually, whenever the 255 finishes here, I'm going to put like that, okay, and I'm going to just write down wherever I see on the left side. So I'm going to write down 172.34. Everything what is on the right side, I'm going to put zeros. Okay? And that's my network. This is my network. And for this one, I'm going to do the same. But it's this time here, right? And then I'm going to say 172.34.25.0. And as you see, obviously there are different networks. Okay? This digit is different than this one. It's not the same. Okay, so that's how I know. Okay, any questions? That's very important. When you create a network, if you create it or it's already created by a DHCP server, you need to know the subnet mask. It's always there. How are we going to see this in Windows computer? What we do, guys, in a Windows computer, we click on the charm button here on the top. This is called charm button after the version 6 after the version of Windows 7. Let me just minimize this. So if I click on the charm button and I write down CMD, it's coming from command prompt, okay? From command CMD, and I click on this icon which says CMD. What I'm gonna see will be this thing. Now, if I write down the command ipconfig empty space /all, and I click enter, and if I go to the top, well, basically my network would be this one. That's what I'm interested in. Okay? And my IP address, as you see here, is 172.24.7.8. And the subnet mask is 255.255.255.0. So what would be the network on this one? What would be the network address? The very first address. That's how they call it. Which will be it?
169.
No, come on, 172. Where do you see 169?
172.
To 24.7.0. That would be my network. Okay, 172.24.7.8. Now, what would be the last possible IP address of this network, guys? The last one would be 172.24.7. How much? The last possible one. What's the maximum digit I could have here, guys? 255, exactly. So the last IP address which is possible for this network will be 172.24.7.255. So if I would like to write down this, if I write it down here, it will be like that. So 172.24.7.8 is my IP address, right? And as you see, it says subnet mask a little bit beneath. It says 255.255.255.0. And we said when we see this type of subnet mask, which is finishing on 255, we see wherever the 255, the last one it is, and we just put a line, an imaginary line like that. And then on the IP address, this guy, we just change with 0. That's all, the very first IP address. So basically my network address here would be 172.24.7.0. That's the very first address, which is called a network address. That's the name of my network. We're not going to call it anymore network 1 or network 2 or network something. It's 172.24.7.0. Okay? The very last address, well, basically I could change from 0 to 255. 172.24.7.255. I don't change anything else because that's where the line goes. Everything on that side is called the network portion. We never change it. It's always staying. This one is called a host portion, and it's changeable from 0 to 255. We never use the very first one and the very last address. So we never use this one in our wherever we design, and we never use this one, which also is called a broadcast address. We never use both of them. We use everything what is between them. From 0 to 255, how many addresses? From 0 to 255. 256. 256, because it's starting from 0. We said the very first one and the very last one we don't use, so -2. So we could use 254. 254. It's called a host address because in this very room I could have up to 254 computers. That's why it's called. Okay, up to 254 computers, which is not good again. Going more than 100 is a lot, but theoretically I could have up to 254. That's what the network means. You see, it's very easy. Well, we could do it a little bit more complex, and you're going to do it much more complex when you start doing it with Cisco. But for now, that's what you need to understand. An IP address and a subnet mask, they go together. They're not interchangeable because the network mask, you see, if it's a different network mask, obviously the network address will be different, hence the network will be different. And if I would like to go from one to the other, then I need a device which is called a. Everyone's okay? I swear. I swear. It's okay. For now, let's leave it like that. Let's leave it like that. See what you're gonna read when you start reading about this. Okay? Try to understand as much possible. When you start doing Cisco, then you're gonna have a lot of it. You have four parts, and it's mostly this, and you need to learn it to do it by in your hand. In your hand. Actually, people are using fingers and the hand, and afterwards it's working very fast. When you get it there, it's very, very fast. You could do it almost in a second. And very complex stuff. Okay? Questions, guys? Now let's speak about the protocols, guys. Tell me what is a protocol. I already mentioned to you. What's a protocol? Set of rules. In this very room, tell me one protocol. One protocol I'm using at the moment. No. I'm asking for a normal protocol. Аз, ако заговоря сега на български, какво ще разберете от това карта? Или ако по-били ви отговорите на вашия? What's the protocol? Yeah, that's the same thing. What's the protocol I just changed? The language. We have a protocol. We have a set of rules. Here in this room we don't speak Bulgarian and we don't speak, the Punjabi. Okay, we speak English so to understand each other. Okay, and that's one of the protocols. The other one is you guys took a long time, right? The other one, don't use internet when we do the, when we do the exercises and stuff, right? Stuff like that. These are simple protocols. Okay, there are some protocols which are working together. Okay, several, maybe two, maybe three, maybe four. I mentioned the TCP/IP protocol in general is working together. Now, for the people who trying to program and who will be starting programming very soon, one of the most used protocols nowadays is this one. HTTP, Hypertext Transfer Protocol, or the secure version of this guy. Okay? So that's or HTTPS. Well, that's the protocol which helping one host to get to another host somewhere in the internet and to get the content of it. Okay? If it's a web server, they will get through a kind of communication and they eventually will be connected to each other. Okay? So that's the protocol which is in charge of this. Now, you need to remember, guys, every protocol is working on a different port, also called. So this guy is working on port 80 or port 8080. Two ports. This guy is working on port 443. Now, these are the standard ports, but they might be changed. They could be changed, and most of the time they're changing because people, normally they know which are so-called used ports or well-known ports also, and they try to hack them. So if you don't want to be hacked, the easiest way is just to change it. Okay, so there are ways that to be changed. Now, there are altogether 65,535 ports in any computer system. Okay, 65535. Now the first 124 of them are called well-known ports, 1024. And everything else is also called ephemeral ports. You could remember, you don't remember, doesn't matter. For people who go through Cisco, you need to remember. Okay, so as you see, guys, some of them, even though are well known, they're not in the first 1024. So when we're talking about well-known ports, it's not always the very first. That's what the theory says. Okay, but as you see, there are some which are more than 1024. Okay. Now, the beauty stuff. You have the understanding of the network. It's layered. It's made by layers. So people do the stuff so complex that at a certain point they say, okay, we started from somewhere, but we've forgotten from where we started. So what was this? Okay, so they call the process analysis and synthesis. So basically, you create something which is very, very complex, or lots of people are creating it. Afterwards, someone who is trying to understand what is this, obviously because it's forgotten already what it is, they analyze it. So they chop it to parts, which means logical, you know, every one of them. And then they do synthesis when they understood every part how it works. And they say, okay, now I know how it's working. They put it back together, which is the synthesis. Okay, that's the philosophical way of thinking. Now, once again, people tend to do stuff very, very complex, and afterwards we are lost, and we need to understand what we've done. Okay, so again, so that's why the layered model. That's my interpretation of this. Don't do. You don't say, you know, that's what it is. You say that's on the book. That's very nice model and whatever. For me, that's how it looks. So the layered model nowadays is called OSI model, Open System Interconnect model. Open because it's open. There is no licensing. It's free. Open System Interconnect model, OSI. It has 7 layers of interaction. What you need to remember, because they show it there. Well, there is another model which is called TCP model, which is a little bit older. And nowadays, when you describe how the networking is done, basically you combine both of them. You combine the both models. So, I mean, I'm trying to explain you as briefly as possible, and I'm recording myself, so you guys afterwards to understand at least the basics of this. Okay. It's very complex. When you start working on Cisco, you're gonna go through it in very details. Now I'm gonna just give you just the very important thing you need to remember. Now the first 3 layers, the first top 3 layers, are also called application layer. Well, it's application, transport, and another. So these 3 layers, the application is there. All of these protocols, we're talking about them, like HTTP, HTTPS, maybe SSH, maybe RDP and stuff like that. All of these protocols which are on the server part or on the computer part of something, they operate of these three first layers, which I'm do as only one. Okay, so this is layer 1, 2, and 3. Well, actually it's 7, 6, and 5. Okay, you have 3 layers, not 4. Okay, so these 3 layers here, this one here, I commonly say it's application. It's not application. There are transport. There are 2 additional layers here, which we're not going to speak for. Now the next one is called the next one here, number 4. So these are 7 to 5. Number 4 is called the transport layer. Okay? In the transport layer, there are something which is very, very important. Here the TCP and another protocol called UDP, they exist together. Well, they live here. The type of devices we know here is a type of router we commonly know as firewall. And the ports resides here. When I say a source port and a destination port, that's what resides here, guys. You have the source port of application, and you have another one, which is a destination. So, from which one it goes and where it goes. Okay, you always have source and destination. In that case, these are ports. And the thing which is combined here and it's designed, it has the common name of segment, network segment. Okay, it's called a segment. But we're going to learn all of this you're going to learn in Cisco in much more detail. Now, the difference between TCP and UDP. The TCP, it's like you're talking on the phone. You pick up the phone and you say your body name. You say, okay, is it Asen on the other side? Hey, Asen, what are you doing? It's Peter, or Peter, or whatever. And Asen will reply, oh, Peter, how are you doing? Everything is okay, you know. So we check if everything is okay. Maybe I might call a wrong number, right? If I call a wrong number, the other person will say, okay, it's not Asen on the other side, it's someone else. So it's a wrong number most probably, okay? So we check to see if everything is okay, which means there is a little bit more information which is possible, right? It's called an overhead. A of information. Okay, you have a little bit of overload of this information, which is checking the both things, what's going on. The process commonly known as three-way handshake. Okay, you're gonna learn about this with Cisco. Now, as soon that's done, the communication starts. The UDP is like broadcasting. You're driving your car, you're listening to the speaker who is talking about the soccer match, or in India, cricket match, or whatever. And you hear that they just misspell the name of your favorite player. But you have no mean to say to the speaker. You cannot speak to the radio, right? So that's what UDP is. It's lightweight because there is no overhead of additional information which is exchanging between them, which is used a lot in the communication protocols. Meaning, if you need to send video, you need to send audio and stuff like that, this is the protocol in use. Because the human eye might see without any problems about 60 hertz per second, so 60 movement per second. It sees, or the human ear might hear something like that. And if there are some drops, meanwhile, you don't see them, right? So if there are some drops, it's not so important for you. You don't see them. So that's why they use this type of protocols to carry this type of information. Okay? So mostly the multimedia protocols are designed by this, the UDP. So that's the transport. The next one, guys, is the networking. Networking layer, number 3. Well, here the IP address resides. Again, you have source and destination IP addresses. Okay? Source and destination IP addresses. And the device which resides here in this layer is the router. Okay? And we normally call the way we encompass the thing, or we combine the thing, a packet. So when you see a packet, well, that's what it is. Okay? And once again, you have source IP and destination IP. Now, on the layer 2, also called data link layer, exactly. The data link layer, which is layer 2, well, you have a device which is called a switch. Okay? It's called a switch. And here the MAC address resides. So the device is called a switch. Now on the layer 3, you have another device which is called a 3-layer switch. So the 3-layer switch is a switch with a router inside. Okay, that's the difference between the 2-layer switch and the 3-layer switch. So here we have something which is called a frame. Okay, and you have again the MAC address, which is source MAC address, and the destination MAC address. These are the two things. And the layer 1, also called the physical layer, well, you have the information in bits here. Bits of information which is going there. Okay, so bits. The devices you could see, well, this is the media here, plus the network interface card. Okay, some people put the network interface card, they put it on the layer 2, so it's possible to see it on this layer as well, the network interface card. But for the medium, for sure, stands here, as well as the electromagnetic interference, which is, moving the electrons direction from one, and bits going from one direction to the other. Okay, so that's how it works. Now, normally what's going on when you try to contact a host on another side of the internet, let's say it's going from this layer, going to that, and then on the other side going vice versa. And basically what's going on, you have a segment, you then encapsulate part of it, which in that case would be the port, and afterwards you have the packet, and afterwards you then encapsulate of it. That's the process code. You remove something of it, and basically afterwards you have the frame, and afterwards you chop up the frame to bits, and as soon as it gets to the other side, it starts to encapsulate. So it starts to put back all of this. So in the beginning you have the destination, afterwards you have the source, and afterwards you have the destination, and that's the way it reaches most of the time to the other host on the other side. But a lot of this most of this, that's what the only time I have to explain this, which is pretty complex, okay? You're gonna do in Cisco, in the Cisco course. Okay, but because I see it's there, you need to know at least what is a packet, what is a segment, which device is there, and how it's used. I'm pretty sure there are a lot of questions. First of all, what I would say, try to read it, and when we see each other the next time, then ask me the questions. Not now, because for now, I don't think you have the proper questions. You need to read it, so to see what is not understanding. So here we have the medium as well. As well as sometimes the NIC card, sometimes, as I mentioned, you could find out the network interface card. I'm going to put this into the lecture so you can get this. Okay, so if there are no questions, take 5 minutes of break and we're going to proceed. Now guys, you're going to see into the lectures, it's a little bit more fancy explained, let's say fancy, like say you have explained a wireless LANs, you have PANs, okay, the personal area network. You're going to see what is this, it's easy to understand. You have the metropolitan area network, but the major thing are the WAN and the WAN, the wide area network. That's the important thing to understand. Everything else, it's in between, okay, and it's not very important. Now the peer-to-peer networks and the client-server networks, we spoke already what it is, and you're going to see properly explained here. Once again, you see you could open whatever is written a little bit more, comfortable if you click on these buttons here. The next thing, you have some activities, so you need to decide, off of description, you need to decide which type of network you're going to use here. That's a cool thing. Now the standards, these are the all parties which are involved in the standardization of all of this. And we need standardization for sure, because otherwise it will be a chaos. Okay, people won't be able to work, and the devices of every different providers which exist. So that's why these bodies are created. You're gonna see what's the reason about this. You're gonna read it. At certain point, you're gonna get to the protocols. They explain what's the function of the protocols, the OSI reference model, and the TCP/IP reference model. You're gonna see all of this, and you're gonna see how it works. The protocol data units, which we already spoke, the data, segment, packet, frame, and bits. Okay, all of this we mention it. We mention even some more stuff. We explain which devices are working and which source and destination thing we're looking for when we are on these positions. It's explaining the message. That's the encapsulation and de-encapsulation protocol. And when you started it, you're gonna see it's explaining what's going on from the web client to the web server and vice versa. Okay, you're gonna see it's a very nice and done very nice, showing the encapsulation process from the data, how you create the TCP, IP, and so on and so forth. Okay, you're gonna see it yourself. Then the encapsulation example, when you receive a message, what's going on again, and so on and so forth. And you're gonna have a comparison between both models. As I mentioned, both models actually are used nowadays interchangeably. What I've used basically was the TCP/IP model with the names of the OSI model. That's what I showed you basically. Just here, I still use the data link in the physical instead of the network access. And instead of calling it internet, I call it the network. But I use this type of model because it's more understandable from the people. And as I mentioned, there are two more layers here, presentation and session, which are not important in our case. That's why we look at them, all of these three, as an application. That's all. Okay? Now, you need to do some activity here as well to learn them better. And you could see how the device is listening to the wire, okay, when they are connected. This is an important thing, the CSMA CD, the carrier signal, the carrier sense multi-access and collision detection. That's what it is. Well, that's how the networking are working today. That's why they're called Ethernet nowadays, because eventually the devices are able to understand when there will be a a collision on a network, and they could prevent it in a way with using this mechanism. You're gonna read about this a little bit more. Okay, now you're gonna see the Ethernet cable standards. It started with category 3. Nowadays we have category 6A and 7 even, and it says how much speed they will allow you. Okay, well, 6 actually could go even up to 10 gigabits per second. But it's not only the cable itself. You're gonna see further the cables. Actually, you see here how it goes on our switch. You see above the switch there is a black thing where the other side of the patch cables, this short cable is going on. Well, basically what's going on, one cable only from our core switch from the room which is next to this, the server room, going out and coming to this switch. So actually it provides us with the internet. Okay, this switch segments the network to the network which we are, 172.24.5 if I wasn't mistaken, right? That's our network where we reside. And afterwards, all of these cables, every one of them goes to one of these patch panels, how they call it, because basically the cables on the other side are patched, okay? And it has a female portion where the cable goes out of the switch and goes out, so it goes in. So that's black thing is called the patch panel. And on the back side of the patch panel, on the back side of every one of these ports, there is a long cable which through the wall goes to the next to you guys. You're gonna see on the wall there are these patch plugs where actually the back side of the cables goes. And afterwards with the short cable, well, here maybe 1 meter, here somewhere about 3-4 meters cable. All the hosts are connected to basically to the switch here. Okay. Well, the long cable which is going from the patch to the wall patch cables actually they are constant. These cables they stay there because they the length of this is constant all the time. Now, if you're going to move these cables on the other side, it's very easy just to buy a little bit longer cable and to use the longer cable. So that's why it's segmented in this way. The cable is segmented, and once again, the patch panels are a very important part of the whole thing. Okay, you have patch panels also in the server room. Everywhere, it's creating kind of modular approach, so it's much more manageable. All of the cables are much easily manageable in this way. Okay, so you're gonna see the standards. You see how fast they are. You're gonna see the how this protocol, which are the wireless standards as well. You're gonna see here there are the wireless standards. What is the speed there, and so on and so forth. How the wireless security is done. You're gonna see the different ways of this. You're going to see what the modems are doing. Well, there are 3 different types of modems, at least into the home, small and mid-sized offices. Well, the analog modem is what we know from the, at least what I know from the beginning of my career and before this. Now, let me just blow it works, guys. I don't hear the sound though. I don't know if you remember, guys, this thing. But that was the first thing. That's the analog modem. Now it's connected. It's connected to the phone, and that's what's going on. And then you have connection, eventually. Okay, that's how it goes. So that was before. Now, don't get me wrong. Still, because it's free, still people are using it, but it's very, very slow. It's just for very specific thing is still used. Now there are 2 major things up to the mid-size, let's say, enterprise in use. It's a DSL modem, okay, and it's the cable modem. Now the DSL modem, basically what it does, that's the phone line. So the internet goes through the phone line. The major provider of this service is called Bell. Okay, that's what the Bell provides you with. Now, the cable modem on the other side, it's using coaxial cable and the cabling standards for the cable television. And basically, that's how you have the signal. Then the signal is coming to your house with this standard cable, which is 4 times bigger, well, 2 times bigger than the telephone cable. Like we call it RG45 or UTP cable also. Okay, so it has 8 instead of 4 different wires inside as the telephone cable, which is called the termination of which is called RG11. RG45 or the UTP cable, it has 8 inside, which are twisted around each other. And I explained you the last time. The twisting is because you need to avoid the electromagnetic interference, which otherwise will be present, and which will slow down the whole communication, will stop the communication. That's why it's twisted. Okay, that's why they call it unshield the twisted current. Okay, so that's the major way of communicating and getting to internet. The provider of cable here in Montreal and the area in Canada is Rogers. Okay, and the last mile of Rogers, how they call it, is the major partner of them is called Videotron. Okay, so Videotron is the major player on the market, but the Rogers is the company which is providing the. So that's basically about the modems. That's what it is. Well, you have other ways to get internet, obviously. You could get internet from your cell phone. Okay, so or type of this type of internet. Okay, you could have internet as well as from satellite. Okay, that's the way how the rural people who are living outside of the networks, how they get the internet, as well as the military, obviously. Okay, if you're in the middle of the desert, you have no other access. Instead, you use the satellite and stuff like that. Okay, so there are different ways to get the internet, but these are the most common ones. And this one is still in use for just troubleshooting purposes, but it's obviously very slow and outdated anymore. These are the major ones nowadays. Okay, there are more. Now the next thing which you're gonna see here, hubs, bridges, and switches. No one is using hubs anymore. You're gonna understand here. They will explain you about the collision domain and how you could avoid collisions and stuff like that using instead of hubs using switches. Well, the bridges were something between hubs and switches. Now, don't get wrong. Switches are 2-layer devices, and the hubs are devices on the layer 1. They are not smart devices. Switches are very, very smart devices. You're gonna read about this here. It's very easy to explain. Wireless access points and routers, and I told you guys the wireless access point actually is the wireless switch. It's switching wirelessly devices, so it's creating a local area network wirelessly actually. And if you would like to get from one network to another, basically you need then the wireless router. Once again, if you need to go from one network to another, you need a router. If you need to switch within the network you to have a lot of people connected or a lot of hosts and devices, well, then you need the switch or the access point if that will be done wireless. Hardware firewalls. Well, the firewall, guys, is used mainly for. It's used mainly to firewall to filter wherever is coming out of internet and sometimes wherever is going from the network inside. Okay, so basically the firewall is very important part of the network. Most of the routing devices, they have it implemented, or they might be created as a separate hardware devices as well. Well, they show it here especially because Cisco has a specific course design, a specific CCNA course designed for firewall, which is the CCNA security. Okay, so they work with their firewall appliances, which is called ASA. Okay, so I guess that's why they emphasize, as well as in the enterprise grade environment. That's what you're gonna see. Firewalls, which are real routers there, and I mentioned to you guys they work on the layer 4 of the networking most of the time, of the networking model, the IOS, the open system model. Okay, interconnecting system model. Now The patch panel, I just speak a little bit. We spoke what the repeaters here is. If you need more than 100 meters cable, you use the repeaters. Power of Ethernet, that's an important concept when you're gonna get to the telephones. Well, most of the phones, they're devices which most of the time they're taking the power out of the switch. So they don't have additional power there. They're taking it from the Ethernet cable which is they're connected through. So in that case, the port of the switch is supposed to give this power. So that's why they call this specific type of switches which has the power. They could power up devices, power of Ethernet. That's what it is. Okay, so that's very easy to understand as well. And you have some activity here to play with as well. Coaxial cables, even though they're used in nowadays, there are not so many like before. They were used before much more. Nowadays, the twisted pair cables are much more used, and lately, especially for long distances and very high speed communication, the fiber optics. Here's the twisted pair, how it's done and why. The colors you're gonna see how it goes. That's these are the features and the standards of the twisted pair cables. Here there are two schemas, the T568A and T568B, and what type of cabling you could have with this and which type of devices they will be used. Well, notice that today is not very important to use straightforward or cross cables because the devices themselves, they have some processors on their network cards which understand actually which type of cables are connected, and if they need to change the polarity of the cables, they do it themselves. So nowadays it's not so important, but still you need to know how it is done and what are the standards. And it's there is actually here you could play. It's a virtual activity you could play and to see if you're doing it properly. Well, there is a lot. I would say, guys, skip this lap. You don't have, and the packet tracer as well. Skip this one. Now there is some explanation about the fiber optics here. What's the type of the fiber, medium, optic connectors, which are the connectors, and here a little bit of the network addressing and IP addressing, which I already spoke. You could see also the IP version 6. Okay. Address here, that's something if you need to do it by hand, that's how it's done. From the graphical interface, you could do it from the command line as well. That's the IP address format. We spoke IP version 4. We spoke about this. Classful and classless. I mentioned, guys, that there were classes A, B, C before. Well, that was the classful schema. At this point, the subnet mask was fixed. When you see a class A, well, that's the first octet which is supposed to be, and the subnet mask was always this one. B and C, and there were D and E and F. Nowadays, guys, there is no subnet. Well, the subnet mask might vary, might be completely different. Not only this one for this A, for B, and for C. It might vary. It's not anymore only one. Okay, and that's why it's called classless, because there is no any more classes actually. Even though I said A, B, C, just because before this they were used. The easiest way to remember before and after, think about year of 2000. Okay, before year 2000 it was mostly used the classful schema of networking. Nowadays, or after year 2000, basically we're using the classless schema. So we don't call the subnet mask anymore subnet mask. Actually, we call it the CIDR. Okay, we call it different way, and we could actually show it on the right side as the number of the bits which are taken. So the subnet mask which I showed you, 255, 255, 255 for this one. Yeah, this one here. So let's say here I get the IP address of let's say 10.057 with the subnet mask of 255.255.0.0. So 255, these are 8 bits, right? Remember the 255, it's all 8 bits once. and another 255, another 8 bits. So 8 bit plus 8 bit plus 0 bit plus 0 bit means 16. So basically I could set, this is my subnet mask 16, or it's not anymore called subnet mask, it's called CIDR. And if you remember, or if you see it from the from the lectures there, actually when it starts with 10, basically it's supposed to be, before it's supposed to be a class full A address. Well, the default subnet mask was 255.0.0.0 or 8, because I have 8 symbols. Now, as you see, I could use 16. I could even use something completely different than 16 even. I could use 30 here. Okay? I could use something like that, which will be completely different subnet mask than this. Well, that's the classless model. Okay, the class full was straight. If you use the class A, the subnet mask is 8. If you use class B, the subnet mask is 255.255.0.0.16. If you use class C, the subnet mask is 255.255.255.0 or 24. And that's all. The 24 of side. Nowadays, here and here might be whatever you want. Okay, and that's why it's called CIDR. I mean, it's classless inter-domain routing. That's what it's called. Okay. Now, getting to the end of the lecture, I guess. Number of IPv6 addresses. You're gonna see how it's organized. IPv6 address formats you're gonna see, and there is a video here. You could watch the video about IPv6. It's I guess it's interesting thing. Static addressing. What is a static and what is dynamic addressing as well? Dynamic addressing is when you use a device on the network or server. Silence, guys. Guys, silence. So dynamic addressing is when you use a device which is called DHCP server. Dynamic Host Configuration Protocol. That's what it stands DHCP for. Okay, Dynamic Host Configuration Protocol. So if you're alone here in this environment, then you need to put IP addresses of all of these 700-800 computers. You could get a week of work. Okay, so that's why these devices, they're set it up in a way that they're giving to every host a specific range of IP addresses, which are designated by the administrator, and actually they receive the addresses automatically. That's what the DHCP stands for. Okay, and that's a specific server which is doing this type of thing. If you would like to show you how it looks like, I'm gonna open one of our computers, which is on the network. Here it is. So here one of the servers. I'll open this guy. Okay. I'm gonna connect to it remotely. Okay, that's a server operating system, as you see. Guys, it's different than it's different thing than the client operating system. This is especially Windows Server 2012 R2. Now, if I click, that would be the DHCP here. You see, this is the DHCP. If I click on this icon, it will open how my DHCP here in the school is designed. Okay, here it is, and IP version 4, and here there are scopes. That's the classroom 1. You see 172.24.20, classroom 2, 3, 4, and so on and so forth. 4th floor, administration, IT area, wireless, and so on and so forth. You see all of these guys, as you see, are the scopes. Now, if I click address pools, that means how many address lists. I'm gonna see all the devices which already taken the addresses. Yeah, and scope options, if there are some options here additionally to this, and policies if there are applies. So that's how it looks, guys. That's what the administrator do, and afterwards the device is receiving. As you see, there are several networks here, not only one. Okay, it's sending IP addresses to different networks. That's how it works. Okay, and actually the devices, it's very easy to see how they are done. If I click here on this small icon here, that's my computer in the next door. If I do open network and sharing center, and then go change adapter settings, that's the Ethernet adapter, which is interesting. For me, everything else is virtual thing. So right click on this and I'll do properties. Okay, and then I'll come here and find out the Internet Protocol version 4. You see obtain IP address automatically. So my IP address for this device has been taken automatically. Okay, and if I would like to check it, once again, if you remember, clicking on the charm button, writing down CMD, doing ipconfig all, and I'm gonna see. So ipconfig, because my keyboard has been changed. Here it is. Wow, you see how many I'm having here. And if I got that's the one. So this is what I'm having in my room. And as you see, there is a DHCP server which has an IP address of 172.24.1.200. Okay, and my IP address is 172.24.50.52, which means the networks are different. You see, the DHCP server stands or sits in a different network. So there is a router which is helping out the DHCP to send to my computer this IP address. Okay, as we spoke, if there are different networks and they're supposed to connect to each other, you need the device called a router. Okay. Any questions, guys? And let's finish. I guess we're to the end of the journey. ICMP is the ping. Actually, when you would like to check something for connectivity, that's what you do. CMD again, and then you do like that. You do ping Google, let's say, ping Google.ca, and here it is. If there is a successful reply, I'm going to see it here. Okay, and it will actually give me the IP address which Google at the moment is on, which my computer access the Google on. That's the IP address. As you see, it's 172, but it's out of the range of 16 and 31, if you remember. That's what I gave it to you guys, if you remember here. Between 16 and 31 on the second octet, okay? And now I do have here 217, that means that's a public IP address, right? So that's the public IP address of Google which I'm pinging at the moment. And if I go a little bit more, well, there is a lot how to configure packet tracer. Now, role of the transport layer. We spoke about the TCP and UDP. I explained you the difference. Well, you're going to find out some more here in addition, which I'm saying it's more practical and it will be in a good explanation here. So I would suggest you guys to read this and to see how it works. And the protocols which layer on the transport layer. Okay? And all the other protocols, you see, they're very well shown. The TCP explain again, the UDP explain again, the port numbers, and some of the most important you need to memorize. And TCP versus UDP, some other activities, and that's all, guys.